of weekly hobby kernel gardening. As usual, thanks for joining. And as usual, if you're watching the recording and you're strapped for time, probably just skip like to the end of the stream, because that's usually when the best stuff happens. But today we're back in this area where we usually are, and we are working on virtual memory, as we have been. And also let me do a quick hello in the chat. I think last time my chat wasn't working, like my chat thing. Okay, I'll do one more test because yeah, last time it just didn't have people's chats in the recording, unfortunately. But it seems like it's all working this time, which is really good. Also, I'm trying something new. I'm playing a bit of music in the background, but I actually can't hear it because I can't concentrate well if there's music. And so I think only you can hear it, and I am unsure if it's too loud or not or whatever. So I maybe will add like a text box. I'll maybe edit the text box to somehow add this. Okay. Oops. Shit. One second. Is the music too loud? Okay. So now, yeah, would be curious about anyone's thoughts on that. But anyway, I feel like we should just get going. We are back exactly where we were last time, and I need a minute to kind of remember everything, but we have been doing these exercises from the MIT class, and I have been working on exercise 4, which required me to implement these 5 functions, and I spent all of last stream doing that. Page insert was the last one. And I am not sure if any of this is correct, because I wasn't able to run it. I didn't have enough time to finish all of them and then try to run things. And so that's kind of what I planned to do today, is like actually try to run this code and then probably debug it a lot, because it's probably wrong. I probably have bugs. So yeah, but I didn't quite finish here, though. I remember kind of being very unsure about this last function, and so I want to take some time just to make sure about that. Just quickly checking the stream, making sure it's good. All right. Yeah, I'm kind of concerned about the music being too loud. I can only see the volume levels, and they're kind of peaking kind of low. I'm not really sure if they're even that audible, but whatever. Maybe someone can tell me later. Okay, but let's get back into it. So we're running this function page insert, and the goal is to map a physical page at a virtual address VA. So given a page info pointer and a virtual address that it should be mapped at, and some permissions, manipulate the page tables to make that like mapped. And there are a bunch of requirements. Yep. If there was already a page, right? It was like if there was already a page there. I'll bring up my visual, which has come in super handy. So we have like this thing we're trying to like map basically, which means this full chain, the full chain needs to be complete and pointing at the physical page. So there's already a page mapped, it should be page removed. And page remove is a call to our physical memory allocator, which, what does it do again? It, given just a virtual address, it looks up the corresponding page and then calls page decref. Hey Drew, nice to see you. Can you tell me if the music is too loud or like too soft or whatever? Or if you can even hear it at all? Yeah, I think you're one of the first people here. I'm not quite sure about that. Good to see you. Yeah, we're calling page decref, and that is actually okay. It's like this long kind of chain of things that eventually calls. User can't hear music at all. Okay. In that case, it's probably too loud, too quiet. So let me bring it up slightly. I brought up the level a little bit. Not sure how it's sitting. Okay, page decref. Right, eventually calls page free, which is actually part of the actual allocator. Okay, nice, you can hear it now. Okay, yeah, it was just something I wanted to try. I thought it might be kind of fun to have a bit of music going, might make a cool vibe, but personally, I can't, like, I can't concentrate with music, so I don't have it going for me, and so I can just see like the audio level in the streaming program. Okay. Yeah, and it's peaking around what negative 30 decibels or so. So apparently, that's a good number to remember for next time if I decide to keep doing it. Hopefully, you can still hear my voice pretty well though. Yeah. Anyway, page remove. Yeah. So this is kind of like a high-level function. Given a virtual address, it does the internal dirty work of like looking up a struct page. And yeah, and then like pretty much freeze it actually. So, right. So, yep. So if a page already existed, yo, digitalized, what's up? Nice to see you. So yeah, just walking through this again. If a page already existed, and we have this new page we're trying to map at the address, we should basically kind of free that existing physical page. That's what this is saying. If necessary, on demand, a page table should be allocated and inserted into page table. That's the situation where the virtual address doesn't even have a page table yet. Like the virtual address is just like belongs to a section of I guess 4 megabytes, because each page directory is for each page directory entry corresponds to a 4 megabyte region. And so if a pointer, if we're trying to map a page to an address where it's in the middle of a 4 megabyte region that's like completely not mapped, we will then need to allocate a page table. So we can complete this full chain that eventually points to our physical page. So that's that one. PBRef should be decremented if the insertion succeeds. The TLB must be invalidated if a page was formerly present at VA. So this one is easy. The PBRef just gets decremented. We're kind of doing that here, close to the end. Digitalized. It's not quite, but we're getting there. We are, but we are still a long way away from mmap, I would say. We are still setting up the really basics of just virtual memory at all whatsoever. But eventually, yes, these are really kind of foundational routines that will later be used, probably for like mmap and stuff like that, I believe. Not sure. I haven't read further into the labs, but that's what I assume. TLB must be invalidated if a page was formerly present at VA. So what does that mean? That means, okay, we have our new page, we have the old page. Yeah, and so basically, right, remember that I kind of want to just draw a little illustration to help us remember what the TLB even is. It also help myself remember it. This weird arrow and stuff. Okay, and I want to get rid of this. Actually, I think again, this is kind of weird. What the best way to illustrate what the TLB is with a table, I believe. Because, so here's my kind of like layman's understanding of what the TLB is. It's like a cache, and it's a cache of the mapping of the virtual to physical mappings. And so in one, like, in one column, we have like all these virtual addresses, you know, like these big things, and then it might map to like a really small physical address, for example. And so we have all these like mappings. There's also other stuff, probably like permissions and stuff too, but this is conceptually the idea, and it's caching the result of walking the page tables. And if we're modifying the page tables and doing certain operations on them, we might invalidate the TLB and like make the cache inconsistent with the actual state we just set. So for example, if the current TLB has an existing entry that caches some virtual address to point at like this hex 1000, which is say this is what is, but then now we're doing, now we're modifying this to make it point to our other physical page, which is say is at hex 2000 or something like that, or 5000, then it's important to make sure we don't continue to have that old information in the cache, because that's what's referenced first. And that's just, okay, that's why we need to do that. Yeah, I was never good at this in uni. If I find time, I'd love to get into it though. Yeah, I never took a class on this in uni, which is why I'm here right now, trying to learn this stuff. Yeah, I've always been very curious about it though, so yeah. Right, back to the code. And yeah, I think I was kind of struggling with this part. It says if a page was formerly present at VA. So specifically, I was kind of struggling with this part at the end. There's like some corner case. And then there's a corner case. Make sure to consider what happens when the same page, physical page, is reinserted at the same virtual address in the same page dir. However, try not to distinguish this case in your code, as this leads to bugs. There's an elegant way to handle everything in one code path. Okay. Right. Okay. So then I remember I broke it down into a few different things. I broke it down into like a happy path and an unhappy path. And called the happy path is when there was nothing there already. And so in the happy path, there's nothing there already, and the page table might not even exist. And what do we do? So our main inputs here are, I'm just looking at the PA. Yeah, this is not used until, it's a bit confusing. Okay, basically, step one, the most important, step one of this is first looking up the page that corresponds to this virtual address. Give me 1 second to understand, to bring that back into my working memory, what's happening there. So we have this page lookup function. Right. So the goal of this thing is, and I'm not even, I think there's probably a much better way to write this function, but this was the most simple way I started out doing it. And it was just the most intuitive way where it's like, first thing I need to check is there a thing there already? Does this virtual address already correspond, and is it already mapped? And we wrote this function called page lookup last time, which does this. You give it a virtual address, and it walks the page directories and produces a page table entry if it could find one. Otherwise, it returns null. But if it can find a page table entry, it then goes further and actually determines the physical address corresponding to that page table entry. So this pointer basically, and then it goes all the way and converts it into a page info struct, which is kind of like it's kind of like a handle to a physical frame. When I rewrite all this code, I might use the word frame instead of page because I find that kind of confusing. Okay, so that was the first step one. Is there something there already? And then it's like, okay, it's null, which means no, there's not something there already. So that means we can move forward and try to get a page table entry that corresponds to the virtual address we want to map. And we can use page_walk, and we can even set the true argument to have it create page tables if necessary. And this will only fail if we are out of memory. Pretty sure that's true. If you pass in true there, the only place it'll fail is if we run out of memory. So this should not really be failing at the moment. And but if it does, we can just fail with enomem, which is kind of what I have doing. Go to fail enomem. But if we get past that, that means it successfully wait a sec. Yeah, it successfully got a PTE and even maybe mapped this thing, got a pointer to this. And then now we can just kind of set the PTE into the correct state to point to where we want to point and also set the permissions. And that's what we do. And I have been zeroing things out because and then I'm using the OR equals operator to OR the bits into it. So it's important to make sure there's no lingering bits. Right, and then I'm adding kind of, yeah, in a weird way, I'm like doing it in 2 steps. I'm adding the physical address, and then I'm adding the permissions. And I'm wondering if I need to invalidate the TLB or something. I kind of think so. Or it doesn't, but it didn't say I needed to. Interesting. Yeah, okay, I don't really understand this very well then. I don't understand why I don't need to invalidate the TLB. So in this case, just to like mentally walk through it, in this case, there wasn't an existing mapping because that was like the whole point of this thing. There was not an existing mapping there, and we're creating a fresh one. So I guess what would happen then? In that case, like this is me totally guessing. I guess the CPU is going to go to the TLB. It's going to see that there is no entry for the virtual address to look up. And then it is, I guess, going to go to the page tables and like walk them and stuff. And then we're set up to do this. And then it caches that result. I guess it's not going to just like outright reject. Yeah, if a TLB lookup fails, I guess what happens next is then it goes to the page tables. That's like how caches like work, I guess. Which would explain why we don't have to invalidate the cache. Okay, 20-second break. Okay. Nice. Okay, so now I'm just adding this comment. Okay, no chili flush, and then that's pretty much successful, I think. And then we can just finish the function, which means increment the ref count on the PP. And the ref count, I'm still not totally sure about what it does, but I had some notion of tracking how many like virtual pages are mapped to the physical frame. Something like that, I believe. Yeah. Is that some sort of 2020 timer? Yep, definitely. It's called Timeout. It's like this Mac app. And I make sure to always stand up, stretch, and look into the distance every 20 minutes. Okay. In the other case, there was actually already a physical page there. And that means we know this thing was already there. And so then we're trying to now we're just trying to get the PTE and then reassign it and point it somewhere else and kind of rewrite it. And therefore I'm using the page walk. It's very similar to what happens above, but I can even assert that the return value is not null, because that should be guaranteed by the fact that this is not null. and then doing a very similar action, which I think is right, but I'm not totally sure. But I think, yeah, set to 0, assign in the PA, assign in the perm. Yeah, probably a better way to do that, but that's for later once I'm sure this is working. And then kind of like invalidating the TLB at the very end, because this is the code path where we're pretty confident we need to do that because we are changing the mapping. And then there's like this little corner case that we need to handle. And that's this thing where do we need to call page remove or not? Again, what does this do? Like, kind of interesting. Yeah. Similar app for Ubuntu. Yeah. Yeah. I think a long time ago, I used to have some like random cron script or something that did this, and like I think there was some easy command line you can use to pop up notifications on Ubuntu, so something in GNOME maybe. But yeah, it was a bit janky. Okay, okay, I think I already found a bug. Page info pointer. Okay, I already found a bug. It's not correct to pass. Oh, this is so interesting. Wow, okay. I accidentally passed in page info pointer to page remove, which is totally wrong. And I'm going to delete that. It's wrong because the type is totally wrong. The type of page info pointer is the struct page info, and page remove takes in the virtual address. And what's interesting about this bug is that the compiler, I believe, doesn't warn on it or anything like that. I don't see a compiler warning, and I think I have W error on anyway. So no warnings, and that's because it's a void pointer. And when you use void pointers, you lose like all your type safety. And that's, yeah, type safety means when I pass in a wrong type into something, it will tell me I'm making a mistake, basically, and will check for me. But by using void pointers, I'm like giving up all type safety, which this is an example of. The actual thing to pass in is the virtual address, which is VA. So I already found a bug, first bug of the day, and I didn't even need to run the code to find it, so that's kind of nice. Okay. But then the question is, do we call page remove? Page remove is that thing. It's kind of interesting that it's actually very inefficient the way it's happening now. And it's just the way the lab kind of has guided me. But this function takes in a virtual address, and then it goes internally and looks up the the page info, but I literally already did that. So it's kind of redundant. It's like, in actuality, what would be actually efficient is if I pass in the page info struct that I already have. And then it can just avoid a bit of this work and basically just decref is the main thing. So anyway, that's like a little bit inefficient maybe, but whatever. It's not a correctness problem. So the situation is where there was something already there. We have now basically kind of like made this point here instead. Forget this arrow exists. It's like now pointing to our new frame. And we need to kind of, yeah, now we're like done here with this physical frame. And it's time to, wait a sec. Wait a sec. But it's time to like let it go and call page remove. But then what's going on this line? Why? Because that's gonna mess us up. That's gonna undo what we just did, I think. Why is that there? Is that, If there's no physical page, silently does nothing. The page table entry should be set to 0. Interesting. So that means, okay, so it is apparently within the bounds of what this function is supposed to do is set the page table entry to 0. So it's like, okay, we're done with this thing. Let's let it go, wipe this out, and let it go and wipe the page table entry out in one operation. So that actually means I have an ordering bug. Because like in my current code, my current idea was to like set this pointer and then wipe the thing out after the new setup is ready. But I was neglecting like to realize that this function wipes out the pointer, which means I would set up this arrow and I would basically drop this thing, which in the process also like deletes the arrow, which makes this point at nothing, which is not what I want. So, okay, second bug of the day found. I think this is kind of easy to handle, but I think we need to move it higher now. Found a similar open source app called Safe Eyes, which does the same thing. Nice, cool. So now I'm doing this higher. This clears the PT, so it must be set it blue. Yeah, I don't love adding all these comments like this. This is not what I would call ideal coding quality or style, but I'm just trying to get this to work. So yeah, because it's so error prone. Oh shit, unlisted. Oh really? Crazy. Thanks a lot for letting me know. I did not know that. Damn. All right. Thanks a lot, Drew. Yeah, I totally didn't know that. I think I was like testing something early on unlisted. Cool. I just made it public. Thanks a lot. Okay. Right, so yeah, it's so error prone to have like these like comments saying this needs to be before that, stuff like that. Okay, so now we're clearing the page first. We can already determine that info pretty early on. We already have all the info we need to determine if they're the same page. If they're not the same page, then we wipe out this thing, clear this thing, and then now we're fully ready to set it later. And let's see, it would be kind of cool actually to use this feature we built earlier where page lookup can return a PTE. I think I want that actually. Okay. So I'm going to pass in PTEP, and then I can yeah. So then I don't need to do this page dir walk anymore. Yeah. Yo, G. Andre. Came across the channel earlier, couldn't sync with your work so far. It's going well. Thanks for asking. I've been working on this MIT course, and I've been working on virtual memory. And I already found a bunch of bugs from my work last week. Because I've just been like kind of reading the code again with a fresh mind, and also a bit more critically. And yeah, I'm finding some bugs, and soon we'll be able to actually try to run it. But before that, I'm really trying to get this right. So thanks for asking. Okay, so I'm using this feature now where we already look up the PTE as part of the page lookup. And we get that here. Should still compile. Yep. And make sure that it's not null, which in this part of the code, it should not be null. Yeah. And then write into it. And then here's this thing. Yeah, so to be flush. What does it say about if the page was formerly present at VA? So I kind of forget why I was unconditionally TLB flush will be slow. Ah, right. It's like that's right. Okay. So the question was, if we are inserting, we're inserting, I don't know, yeah, I kind of don't understand this edge case that they're talking about. This edge case is like, okay, let's say you have this existing setup, and then you just call this function and pass the virtual address that like points here, and then the same physical page. Bro, speaking the God's language. Hey Krishna. This is kind of a weird, like we're calling this function, passing this thing that's already just pointed to, passing this thing, and it's basically like a no-op. With the exception, and the only exception, like, is that the permissions might actually be different. So we have this perm thing, which we need to do. And so technically, I think technically there is an optimization we can apply. And so the optimization is if it's the same PP, I mean, yeah, and if the permissions are the same as they were before, meaning nothing gets changed here. We don't need to do a TLB flush because nothing changed. It was a total no-op. But if the permissions did change, I think we do, you know, I'm kind of curious. This whole TLB thing. Where can I learn more about the TLB? Paging. Memory typing? No. Caching, translation. Provides software developers information about the relevant processor operation. Yeah, all right. All right, real quick, can I get some feedback about the music, by the way? I actually can't hear it. And I'm just curious if y'all are like enjoying that, or if it's a cool vibe, or like, or what. Feel free to just like leave a comment. I was listening to like my stream earlier with like some lo-fi in the background. It like seemed kind of cool, so figured I'd try that out. Okay. Facility. TLBs, right? Hey Shivang, nice to see you. Hey Barry. Okay, music is chill. Okay, good. Yo, Corey-bot, what's up? What up? That was also, yeah, digitalized. I was kind of like, what if people also have their own like music, like low key playing? I don't want to like conflict with that. All right, 20-second break. Okay, but this is the authoritative source of information about all things TLB, and I don't really want to read it all, but all I want to kind of learn is like the basics. I wonder if I can do that quickly. Okay, in general. I want to play it myself since I'm coding with you on the background. But suddenly started from you. Okay. Yeah, it'd be cool if you could like choose if you wanted the background music or not. But unfortunately, I'm forcing you to listen to lo-fi hip hop. Barry, watching from Nairobi, Kenya. Global dude, also interested in low level domain. Awesome, super cool. Yeah. Thanks for being here. I think we have definitely, anyone that's in here right now has definitely similar interests, I think, so that's cool. All right, let's take a quick read through. In general, TLB entries can map page numbers to page frames, right? Page number being virtual page number, page frame being like physical page frame. These terms are defined. Have I tried Rust? No, I am not skilled enough to do Rust for this. I'm still a beginner, so I'm just doing with C, which is the easiest way to do this. There's like way more tutorials and stuff for doing this in C, and also I don't know Rust, but I do know C. Information, details of TLB usage, gold page feature. Okay, that's all. Okay, blah, blah, blah. Page size, blah, 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 blah. Okay. Details, caching, translation. Individual translations in TLBs. Each entry is an individual translation. Each So reference my page number, following information. Okay, physical address corresponding to the page number. Okay, access rights, which is the literal thing I was wondering. So it's like, what is it? What is in our cache? We have this like, I have this bad drawing of like a like a little cache from thing to thing, but it's obviously like way more complicated than that. It's not just the address. It's like the read write flags, user supervisor flags. No idea what the XD flag is. Protection key. Attributes. Final page frame. Dirty flag in the memory type. Okay. Oh shit. Go back. Access rights from the paging structure entries used to translate linear addresses with the page number. Right? And then from the final page. Interesting. They're being like a little bit weird with this language here. The XD flag. Yeah, exactly. Exactly. I think what they mean by this is that it's not just the page table entry. It's not just this thing. It's actually caching like, you know, all of the different, what is it called? Paging structure entries, which like these are all different paging structures. And then it's specifically calling out attributes from a paging structure entry that identifies the final page frame, which is only the page table entry. And then that entry has some unique things in it, like the dirty flag. And I don't know what a memory type is, but apparently it has that too. And those are things that are not in the entries for like the page directory or the other levels of the page tables. And also, just for fun, one thing that I learned about TLBs that I didn't realize for a long time is that it's not just one TLB. It's actually, I think there's commonly multiple ones for like instruction data, or yeah, instructions and like code and like instructions/code, same thing, and regular data accesses. In the same way that there's like an instruction cache and a data cache, there is an instruction TLB and a data TLB, I believe, and that's kind of what it's saying here. They implement multiple TLBs, but that's kind of like a low-level detail. So this is actually, I mean, this is like a little bit detailed to be like reading through right now, but it is kind of neat because in the code here, it's like there's all these comments saying like when you need to invalidate things and when you don't and whatever, and I could like just take their word for it, but this is really the authoritative reference. So one for RSP and one for like RDP. So RSP is the stack pointer. So in terms of real registers, it would be like RIP is the instruction pointer, and that's like always pointing to like code addresses, and then like basically all the other registers point to data. I don't know how it actually works though. Like how would it? So maybe, yeah, like in the instruction like fetching part of the pipeline, I guess. So RIP contains a virtual address, and so it's going to. I mean, it's a total guess, but like. I think specifically in the instruction fetch part of the CPU pipeline for executing an instruction, my guess is that it's using a special TLB to resolve that RIP into like a physical address. But in the other part of the pipeline, I don't know, like in the instruction like execute part of the pipeline, because I think that's usually how it works. It's like decode, like fetch and decode or whatever, and then other stuff, and like execution is later. in that one, maybe it uses the data TLB or something like that. Yo, Mr. Tote Bag Labs. What's up, Jose? Thanks for the feedback. Yeah, just trying something new. Kind of inspired by you, actually. Yeah. Anyone that's watching this should definitely check out Tote Bag Labs streams, where Jose streams some awesome audio programming, and DSP. Very cool. So, I don't know, this is like, I don't know. I am getting a little bit bored, so I'm gonna go back to the code. Yeah. So, right. Is the page the same? So I'm just gonna document this optimization I just talked about. What's going on? My caps lock is on. Okay. Okay. Be optimized. Case where PP is true and the permissions haven't changed on the PTE. This whole function is a no-op, and we can skip the expensive TLB flush. To implement this, yeah, I'll just wait. Maybe I'll leave it at that. But now I just realized something else, which is kind of funny. Yeah, I'm kind of seeing what they meant here by try not to distinguish this case in the code. I'm just observing this ref count bump. And it's not correct. The way I'm doing it is not correct because of this corner case. Yeah, this is like, I don't love the way this is currently working out. Like, this function is getting very messy. So now I need to add basically another conditional around this to check if they're the same. And I mean, yeah, just to sketch it out, I think I need to lift this into a higher scope though. So PP, yeah, I think this needs to be lifted all the way up here. And so this is like probably like the worst possible implementation of this function. If that is same PP, then bump the ref count. So this, we successfully insert, like map the VA to this page. And it wasn't mapped, wasn't already mapped before. So this is yucky. This is very yucky. All these conditionals. But I think it's getting closer to being correct. And I think I'm ready to make a commit temporarily. I already had a whip. Oh, interesting. Page insert. I'll just make another one. Page insert 2. I think this is more correct, but now the code is messy and there's too much control flow. How do I? Okay. So what now? Now I have, I guess, a choice. I could either try to run the code and see if things work, or I could try to rewrite this and compress it all into like the one elegant way that they're talking about. Do I use stash often? I use it pretty often. Yeah, it's useful. I mostly use it when I have, like, when I kind of like accidentally did two kinds of changes, like kind of like all at once, and I want to eventually commit them separately, and I want to test whether things like compile and work with only one of them. So I can make sure that the commit with only one of them like passes tests and compiles. And so what I'll do there is I'll like stage the part that I want to compile and test. I'll leave the other thing that I'm kind of like deferring for later in unstaged, and then I will stage only the unstaged changes. I only do it when LazyGit asks me to. Yeah, I mean, yeah, like there's certain cases when it's useful, but you'll probably, yeah, realize when you have those. Yeah. Okay, I think I'm just gonna go ahead and run this though. So now what do? I'm just gonna run it and see what crashes or whatever. Check page tests the routines. Make sure it reports success. All right, moment of truth. Let's see. Okay. Right, was that it? Okay. Let's see. Make Kimu. Damn, all right. Didn't work. Interesting. I wonder, yeah, now what do I do? So now it didn't work on first try, too bad. And I guess let's take a look. I'm also kind of thinking, what if I already kind of know this function is like very yucky and probably kind of wrong even maybe. So I could even just try to rewrite it without even looking at the error. But no, I'll take a look. What's going on here? So 960. Huh. Okay, for real though, what check page. So what are we doing? So allocate 3. What is the 0 we do again? It's just the flags. Okay, right. Allocate 3 physical pages. Assert that they exist and are different. There's no page allocated at address. Okay, wait. So temporarily steal the rest of the free pages. Okay. Free list goes. What is? I always forget. This is like our global. Oops. Like our global. Yeah, it's just like our free list. Yeah, it's our head pointer to the free list. And okay, now there's no more memory. Okay, so assert that this returns null. Assert there is no page allocated at address 0. Okay. There's no free memory. So we can't allocate a page table. Okay, so then now we're returning the negative thing. free. Okay. So now free one of these things we had earlier. So now it's the only entry in the free list. And so the next allocation of a page table should use it, which is what happens. So, right, what are we doing? We're passing the page dir, passing in interesting. Passing in a different. Okay, I'm passing this thing, and we're trying to map a virtual address 0, and we have some permissions. And if this worked, what should happen? Let's go back here. Oh, oops, get rid of this arrow. So here's the situation. So so we have 2 physical frames free. It's like 0 and 1. But 0 is the only one in the free list. And we also just kind of like have this random other, I'll call it 1, call this 0. And the goal is to like take this arrow and draw it here. And we're trying to map 1 here. And in the process of doing this, but like, we don't have any page tables like at all, I think, but the basic idea is that this thing, like, yeah, we don't have page tables, and so we need to use the 0 page, and then that gets mapped here, then we'll get an entry into it and point at 1, something like that. And apparently I passed that, and apparently I passed this other one, which checks that. Yeah. Hey Lizard. Thanks. Yeah, music looking good. Cool. Sounds good. Yeah. And I passed this test that checks that the PTE edger. Okay, so PTE edger is a macro that just gets the high 12 bits. You can use it on both page directory entries and page table entries, and it just gets the high 12 or no 20, the high 20 bits. So it's just saying, okay, get the first entry in the page directory, like the first one here. All right, 20-second break. Be right back. And just saying, okay, so it's like, what is this pointer? Where does this point? It should point at the physical frame that corresponds to PP 0, which is like, yeah, the physical memory that backs this, basically. Which is just checking that PP0 was used by the page allocator to satisfy the allocation for this line. Okay, what's next? And then there's the thing that I failed. What did I fail? Right, I failed something. Check VA to PA. What does this do? And I don't know what it does. And it's supposed to be equal to PP1's like what physical to PA, yeah, so to the PP1's physical address. So what's my guess at what this does? I'm trying not to look over to the right. Okay, we give it a virtual address, we give it the page dir. It's probably going to go like look up. I mean, yeah, it's just going to do the translation and return the physical address probably. I don't know what the check thing means. Yeah, what does it do? It takes the VA. Oh, so interesting. This is the idiomatic way that they do the page table walk, which I have not been doing. But they directly use array syntax. I've been using like pointer arithmetic. Okay, interesting. And they have all these macros and stuff. Okay, cool. So take the VA, get the page. Also, holy, what? They reassign the page? That is janky. Okay. So they get the page directory entry. And also, what is going on with the... Oh, okay, there's no way to do -1. Wow. Welcome to C programming. There's no way, like, that's how they return an error code. There's no way to return -1 of the uint. And so they hack it. I mean, they invert like all the bits and like basically return a -1 in a uint 32T. That's crazy. Okay, anyway. Wow, okay. Yeah, LMAO is right. Okay, but assuming that works, it should be present. That's the whole, present. What could possibly go wrong? What? I'm kind of curious then. Let's do some debugging. Oh shit. Wait, I have no idea what just happened. Oh no, oh man. 1 second, I just like hit an accidental tmux command and like wiped out my entire, like what the hell? Okay, very embarrassing. Okay, make Kimu, make GDB, lazy git, Python 3, all right. This Kimu GDB. Right. And I'm trying to do what? I'm trying to break on this thing. Oh man, remote communication error. Ouch. Breakpoint. Continue. And let's no, not step I. We're just doing next. Okay. Honestly, I'm not really sure like what just happened. The debugging support is not super good because I'm like using optimizations right now or something. But then I think last time I tried to disable optimizations and it broke the kernel. Let's do that one more time, right? Well, let's see, what am I going to do? I don't know really what just happened, so I'm going to set a breakpoint. I think it actually failed there, because I have a feeling I didn't set the present bit on any page directory entries. And I remember specifically thinking of whether I should do that or not, or whether I need to set permissions. Somewhere. Man, I'm like losing track of all these functions. I think I know the exact part of the code though. Walk, is that it? Page directory, yeah, it's somewhere around here. Is it? Wait a sec. Is it? No, this is. Outlook. I mean, I think I know the issue though. I'm not setting the present bit. I think I skipped that, but I kind of want to just verify that though. So what was and the way I was going to do that is setting a breakpoint like around here, which is like a little bit awkward to do. Let's see, what 9:15, and I'll continue. And we did not hit that. So that's yeah, it's like returning an error here. And I need to figure out, I forgot which function it is. Like the word permission was used somewhere here. No. Or, page directory? Or was it lab 1 actually? Was it all the way back in lab 1? No, I think that was too early. Okay. So my page directory entry doesn't have a present bit, and I need to figure out. I'm totally forgetting where we set where we initialize the page directory entry. So many functions. Let me go back. Okay. What were the functions even? It's like boot alloc, nope. Page init. That's all totally unrelated to virtual memory, so it's not those. So was it page dir walk then? Oh, maybe maybe, right. I think it was here. Yes, it was here. Hint. But yeah, the bits, blah, 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 blah. It's safe to leave permissions in the page directory more permissive than strictly necessary, but they still need to be present. And I didn't do that. Right, so how did this work? It's like, so first off, it's like, okay, look up, go here and like look up one of these things. And does it point anywhere? This is, no, it doesn't point anywhere. If it, and this is yes, if it does already point somewhere, which means there's already a functional page table present. But this is more of the relevant one, I think. So this is where this is where like nothing was set up. And therefore we are kind of taking the early steps to set things up. And specifically, this is here. And specifically, I think I'm missing like a PTEP, which I think is the present bit. Yeah. Okay, let's see. I kind of want to be init. Or what? Huh, interesting, okay. It's kind of annoying to have to keep setting these breakpoints all the time. Does it remember anything like that? No. Continue. Okay, let's see. Okay, nice. So yeah, that was it. So now I made it past that initial thing that was failing. That's interesting. So actually, because I was kind of aware of that, and I was intentionally interpreting this comment. I've too many panes open. I was intentionally interpreting this comment to mean that you don't need to deal with the permissions bits in the page directory entry, but that's not true. You're safe to not deal with the read and write bits, but you do need to set the present bit. And did I miss that somewhere? I thought I read this quite carefully. I think, I don't know. Yeah. I think that was actually just something that I needed to do that wasn't even mentioned in this whole thing. So, okay, learned something new. So now I'm kind of curious what happens next. So then, yeah, it looks like we are returning. And now we even are back in the main tests at this thing. So I actually passed that test now. So let's just, okay, another assertion failed. 653. Really? Or wait, what? Page ins. Oh, I see. So an assertion failed, but I think that's that was like my fake assertion, or that was like my assertion that what was it, 953 or 653? That was my assertion that I literally left this comment saying, if the 0 page is mapped, this will assert when it shouldn't. And back then, when I was writing this comment, I was kind of under the impression that we didn't ever want to map a 0 page. But it turns out these tests are mapping a 0 page, because that's a really easy page to test, and it's triggering the assertion. So that wasn't actually a bug. That was just me like asserting something that like wasn't technically an invariant. One more time. Continue. Okay. What fails next? 967. Okay, what's next? Should be able to map pp2 at page size, because user is already allocated for page table. Okay, I did not understand that sentence. Should be able to map pp2 at page size. Okay. So in the early beginning part of this test, they have like 3 physical frames, 0, 1, and 2. 1 is used to become the ultimate actual like destination physical address for the mapping. 0 gets used for the allocation for the page table. And then it's like kind of saying pp2 should then page let me just read it. Page insert. So now it's inserting, and okay, it inserted what? At 0 before. So let's just yeah. So let's pretend that let's pretend that we're like looking at physical. This is gonna be kind of messy. Let's pretend this is like a view of physical memory and address hex 0, or sorry, virtual memory. This is virtual memory. So hex 0, so this is like virtual memory. The pp1 thing, oh my god, this is so confusing. You know what? Never mind. Ignore what I just said. I think I was misexplaining it. Anyway, we're trying. So what did we do here? We mapped pp1, okay, to be, yeah. So this is some memory, and it's at virtual address hex 0, say. And then now we are basically trying to stack something on top of it at hex 1000. And it's going to be, we're trying to map pp2 at hex 1000 writable. And apparently that actually did work, but then something else was wrong. So now we take page size and use it as a virtual address. Apparently pp2 was not used, so interesting. I guess I'll probably debug it. So I'll start at 966. Give me 1 second, my doorbell just rang. I need to answer it. All right. I did something weird. I just set a breakpoint. Okay, let's continue. Now we're there, and then we're gonna break a page insert. And also check VA2PA. And now I'm curious what's gonna happen. So now we're, okay, what? Okay, 20-second break. Okay. Let's try that again. So I want to break pnov.z 66. Continue. Let's say I want to step in. Okay. Okay. Null. Is that right? All right. Page insert. So what's going on? So now we're page info p equals null. Which I guess was, okay, what should happen in this case? pp2 and page size gets passed in. So first thing we do, convert this to pp2's physical address, doesn't really matter. Then we do a page lookup with page size, hex 1000. And what do we expect this to be? I expect this so that, I think, sorry, a bit distracted. Right, we look up the page mapped there, and there should not be anything mapped there right now. So I think it should be null, right? But it's not null. It is not null for some reason. So either I'm wrong or wait, let me just verify a few things. So it's that thing again where it's like there's optimizations that are making it a bit difficult to debug this actually, and I actually don't know how to disable the optimizations without breaking the kernel, because last time I tried that, it broke everything. What I'm kind of wondering, though, yeah, so it's like, apparently that was not null. So now we're here. Wait a sec. Because PP was already allocated. Interesting. So now, okay. Now I'm very interested in what happened with the page lookup there. So I'm gonna restart. And I think it's high time I made a GDB init. Which apparently already existed. Page ins. Or I guess I don't really want these active at the moment. But just so I don't have to type this all the time, yeah. Okay. Let's try this one more time. Breakpoint 1 there. Okay, continue. So now I can freely step into here. And apparently all my local variables are optimized out. So no idea what they are, but let's take a step forward. And let's take a step, yeah. It would be really nice to print out some variables right now. Too bad I can't do that. Maybe I have to resort to printf debugging or whatever, which is definitely an option. But for the moment, I'll step into page lookup. So this should be, VA should be page size, which is hex 1000. And now, I guess, do I have to just like really walk through the entire thing? Okay. So now I'm trying to look up. So yeah, tracing through the like all the code. So now it's pagedir. So now we're here. What? So pagedir walk. What happens in pagedir walk? VA. And in this case, so page lookup, and we're passing false. There. So here's my, so in this case we have the VA, which is 1000. And I guess a number of things could be, I did write my own macros. Those could be buggy. But let's do it next. It is, so can I really just not print anything? That, okay, I can print like some random things. Why is that 1023? What? Does something sound wrong about that? Well, yes. I mean, I feel like a few things sound wrong with that. I feel like it should be 0. So we're trying to resolve the virtual address hex 1000. Oh, wait, no. Okay. Hex 1000 is within the first 4 megabytes of memory. And so therefore, it's not going to be a different page directory entry. It's going to be the existing one. So it actually makes sense why it would find something here. But it sounds wrong to me that it's 1023. That's a little bit of a concerning number. It's like an odd number. What? 1023. Okay, what? So each page directory entry maps 4 megabytes. And we're just within the first 8 kilobytes of memory. And so we're using that page directory entry, which 23. I feel like I need an assert. I feel like I need an assert somewhere that physical addresses should be like at least even or something like that. It is also like, what the hell? Assert. Yeah, I'm just gonna assert page table PA 2, right? Failed to find an available port. Oh, okay. I was kind of trying to run a separate one without messing up the current one. Let me just exit this. Okay. So I feel like this should assert. Yeah. Assertion failed. Visual PA. Would be cool to get a stack trace, which I can only do if I'm like running in the debugger. Okay. And I guess I want to break in panic. I guess I kind of always want to break in panic or something like that, but Panic is not defined. Oh, okay. No. Macro city. Okay. Interesting. Wait, what? The assert did not, well, okay, maybe that makes sense. So now the assertion failed, and okay, it's not in a very interesting place. It's the place I was kind of just looking at. The question is who, okay, who is setting? I mean, we are right here. New page. So I feel like, wait a second, yeah. What is new page? Is it correct that these things should always, physical addresses like this should always be aligned, like even, I'm pretty sure. Not only should they be even, they should be aligned to 4K, I think. So we get a fresh page straight from the allocator. I'm just gonna add another assert just to kind of test the waters. I feel like, yeah, there's probably a better way to do that. But I just want to make sure it's aligned on 4K. Probably the better way to do that is with like masking or whatever, but expression must be a modifiable L value. Oh, oops. Thanks, okay. Let's run it again. What? Oh man, okay. Did I not compile it? No, I thought I'm pretty sure I did compile it. I'm pretty confident of that. I was expecting my new assertion to fail, but it didn't. What? Alright, maybe I should just check every single page to walk. I don't think, okay, maybe it's called a few too many times to set a breakpoint there, but Okay, interesting. Yeah, man, this is pretty intense. A lot of code that I wrote, and all of it could be buggy. How do we do this though? Okay, the main thing that was really suspicious was that 436. This is odd. I kind of feel like I need to just like really step through it for these things. Or maybe I should just add print statements absolutely everywhere. Is that also a strategy? I guess it could be. I don't quite know where I would add them though. Hmm. Maybe, I mean, yeah, that immediately looked wrong. Page directory entry pointer. I kind of want to see what that is, though. So I'm dereferencing. I mean, there's like macros I could be using for that, I guess, too. I could try using their macros, such as the ones in the check VA to PA. What are they doing? It's like if you pass in wait a sec, what? Oh, okay, yeah. So this macro is for unpacking things from the virtual address. Visual index, okay. Interesting. What do I do? So I have this very strong suspicion that it's wrong, that this thing is odd. So I think, yeah, that's like the first thing to figure out is like whether that's true. But yeah, the page table PA, yeah, it's a 4K aligned number, basically. But yeah, where does this come from? Page dir, directory index. Okay, just out of curiosity, I'm going to use their macros in case that changes something. PTX. In case I messed up my macros, which would kind of suck and be pretty embarrassing, but I don't think that's the problem. This thing is still failing. So, okay, I kind of feel like I just need to start over. Okay, make GDB, make GDB. All right, 20 seconds. All right, what's going on? Break on panic, break on PMAP, and so now yeah, so here we are at the place, and oh, I was like, is that 1 too early though? Sorry, 66. Shit, that's wrong. Now I'm interested in, well, whatever. Okay, we'll get there shortly. So now we're here, and I am curious how things look. And I was noticing that if you step into this function and continue And continue. Assertion fails within page lookup. Okay, oops. Page lookup. Assertion is within page dir walk. So this very fundamental thing. And maybe I need to make it a priority to figure out how to not have all these variables get optimized out. Can I go up? There we go. L. So yeah, this is the. Wait a sec. What? I guess I'm trying to. Maybe it's time to add some prints. Yeah, I was kind of avoiding that because I kind of forgot how to do it, like what function I need to call. But maybe it is actually time to add some prints. Maybe it's not even that hard. But also, wait, am I? This was kind of a weird thing I did, like set this thing to 0. But this is the place where we initialize page directory entries, right? This is like the single place we are doing that. All right, I'm going to figure out how to hey boot. What was I doing? It's like cprintf, right? It's just cprintf, and I can just print stuff. So let's say I wanted to oh, whoa. I want to print. I always forget how to do this. I'm gonna ask ChatGPT, how do you print in C? How to print F a uint32 variable in hex padded to 4 bytes. Is that really it? Okay, hex %08x. Percent. Sorry, what was it? Percent 0. X. Just gonna try. Copy. And what? Yeah, PDET is uint32t, right? So I'm gonna say setting PD, and that's the final state of this. Just curious, what happens if I do this? Oops, forgot the new line. Okay, so what is hex 3ff? I mean, it is 1020. wait, what? Yeah, something about that. So maybe I'm really screwing up here. Huh. But I also confirmed that. I'm just gonna time to print out. Okay, now we're doing interesting. Okay, wait a sec. Okay, so maybe. Okay. I see. Okay, I think I see. So I was like freaking out because this number was 1023 in the page directory entry, but I was forgetting that is not the full physical address. That is just the frame number. And it might be totally possible that it's like 1023 right now. So maybe that's not the actual issue. And which means I think my assert is wrong. So yeah, this is not a PA, this is a frame number. Which means I think I need to go back to the beginning of the debugging. So, okay. Zooming out for 1 second. What's the high level problem? Like at a high level, we're trying to, we have like a physical page. We want to map it at page size at hex 1000. And we try to do that. And then if that happened correctly, we should be able to then do a lookup on that virtual address and then check that it looks up to the physical address of that physical page we gave it. And currently that is failing, right? That is failing here. And we know it because it prints it out. Wait a sec, what? Oh, wait a sec. Okay, I was looking at the wrong place. Yeah, 974. So we know that it's failing because it prints that out. So that means something is wrong with page insert. Which is where we should step into. Yo, oh, yeah, appreciate that, Shivang, thank you. All right, so we're gonna go next a few times. And now we are here, and we're gonna step. And now, so this is where I was like, so this is where I got all distracted. Or no, wait a sec. Page insert. All right. Page insert. I think I just need to have like a really good understanding of what I expect to happen here. And so I passed all this successfully. This was like the first kind of like actual set of actions. Inserting physical page at hex 0. right? Which concretely looked like this. PP1 got mapped at virtual address hex 0, basically, which required PP0 to come in and get allocated as the page table. So I believe this got set up. And then it did a check and stuff, and like checked that, okay. The adder, PTE adder, which all it does is 0 out the low as well bits, pretty sure. Because yeah, I have all these bits, we're anding. Take the ones, flip everything around. So we have like 12 zeros in the bottom, a bunch of ones. Anything anded against a 0 is gonna be 0. Anything anded against a 1 is gonna be itself. So 1 and 1 is 1, 0 and 1 is 0. So yeah, so we just clear out the bottom bits to get the PTE address and check that it's 0. That worked. And then we check that we see what 0 resolves to, and we confirm that it actually resolves to the 1 physical frame. And we confirm that we both a bumped ref count on 0 and 1, because now they are like in use. Right, and then number 2, insert something else, pp2 at page size. What does that need to do? So that needs to, it can reuse the PDE, it looks that up, gets a page table, and it basically just needs to create a new page table entry and point that, like, can I drag this? Like a little bit higher and like point it at 2 somehow. And that's pretty much it, I think. Like, right? That's what needs to happen. And for some reason that's not happening, okay. And now I can concretely walk through the code and inspect, like statically kind of try to check this. So the way our PP insert works is we first look up the page info to see if something is already fully mapped there. And in this case, it should be no. So that's that's already a really easy check I can just try to do. Page info p pointer page info p. I just kind of wonder. Okay. Oh, I always forget. Interesting. So we had 2 zeros and then a bunch, and then like a thing there. And let's see, is that what we expect? So yeah. Oh, wait a sec. No, wait a sec. No, that's not what I expect. this virtual address page size should not have any page associated with it at this point. One second, I'm just getting a phone call. All right, my friend butt dialed me. All right. Okay, that's already not what I expect. I don't really think this should have something because, like I was saying, we're trying to map a new page. We're trying to map a physical frame to a virtual address that has not been mapped at all before. So this should not be true. So now we can take like a step deeper and maybe try to understand why that is actually returning something. And we can just, okay, so my expectation is that it should like hit this. It should try to look up the VA the virtual address you're talking about specific to a single process. Yeah, like this is even before processes. Like we are like not even ready for processes yet. So we're just working purely on just like core virtual memory infrastructure, like really in the most general way possible. Maybe I'm not sure that's easy to understand. Hey Ismail, I am debugging. I'm deep in debugging right now, and I'm having kind of a hard time with it actually. But I'm making some progress. So my expectation, see, I guess I'm just solidly in printf world now. Page lookup. Okay. It's EP. Right. Just gonna litter this whole. Now I'm getting all confused though, like, oh man. Really, another 20-second break? That was fast. All right, now I'm kind of confusing myself with all these prints because okay. So in this case, this thing, shit. I was trying to figure out why this. Okay. So this print is after this, like, obviously, and if I like scroll up a little bit, so it was clearly returning success, and it really found a PTEP. So that was the immediate chain before this. And then they like, yeah, these two things are not relevant. And so the question is why, yeah, why did that work? So now we need to go look at pager walk, which succeeded. And why? Wait a sec. Okay, so should it have failed somewhere or what? Oh, wait a sec, okay. Oh, wait a sec. I'm like missing something here. I'm only failing in 2 cases. I am totally missing some code. Wait a sec. Or am I? Wait a sec. Or is it actually correct? Interesting. Wait a sec. So I'm saying, get the PTEP. Don't create a page table. It didn't need to because there's already one there. So actually, no, it is kind of correct. Interesting. But wait a sec. So maybe it like actually is correct to have a valid thing here. I don't know if there's no page mapped there. I think that's the thing I'm not doing. I think I was relying on this part to do that. But I was forgetting that page walk will pretty much always succeed. Right? That's true, right? Page walk pretty much always succeeds. It doesn't matter if the page directory if the page table entry points somewhere already. That's not what this takes care of. I think I forgot that. And I was assuming it would return null if it wasn't pointing at something, but maybe that's my responsibility to figure out. No page is mapped there. What does it mean for a no page to be mapped there? Yeah, I'm like missing something here, I guess. I think it's something like if PTE adder PTEP equals, I don't know, 0, go to fail. Maybe that's it. Well, yeah. I'm just gonna say page lookup go to fail 2. So we get the PTEP, and now we kind of examine it, and we see, are you actually pointing somewhere? But what if it was pointing to the 0? What if it was legitimately pointing to physical memory 0? Oh, the present bit, maybe. Oh, I think that's actually, yeah, that is actually the sentinel we need, I believe. Is that right? Page table entry no, wait, what am I doing? And, right. So I have this big thing where, like, if the present bit is set, okay. Not, I don't know. So if the present bit is set, if the present bit is not set, wait, is that right? All right, this is real like C beginner hours here. How do you confidently check if, or wait, it's really just, no. I think it's really just, I'm just checking if the lowest bit, if this bit is set. And the way you do this is you AND, right? To check if it's set. And I'm trying to see if it's not set. So I'm pretty confident this is right. So it's a big number, and we have literally a number 1. We're like ANDing against that, and the 1 has all these zeros, and so it's going to 0 literally like everything else. It's just the first bit, and if there was a 1 there, it's going to stay the same. If there was a 0 there, the whole thing is going to be 0. Okay, let's take a look. Yeah. Okay. 984. Okay, did it still not work though? But at least, okay, go to fail 2. At least we hit that, which I think is correct. I also think I think there was at least one other place I was doing a check based off of whether the physical address was pointed somewhere or not, which I think is wrong. I think also here, the way to do the check is with the present bit. That's how you tell if it's like there's something there. Yeah, this is kind of wrong too, I think. So in this case, it should be actually if page dir entry pointer and ptep. But I'm trying to see, like, I was formally saying if that is 0, so it's also, I think, kind of similar. Thing is not there. I don't really, oh, why is this thing, okay, it's weird. But yeah, I wouldn't expect that to fix it. Okay, but at least that puts us kind of on the right track. And I do need to get kind of going soon. Interesting though, so now what, yeah, so now this thing has 0. So I think that's a little bit more correct, which puts us on this path. Mm-hmm. And now I want to really be taking, I want to take a look at okay, this thing is null. So then we like possibly all right, test 1, 2, 3. Test 1, 2, 3. Yep. So that runs. So we get past there, and now so just curious. I'm going to log this. Insert TP because it should be the same thing that we saw here. No. Oh yeah, I think so. It should be exactly the same. I'm going to add some exclamation points so I know which one I'm interested in. And yeah, looks the same to me. Okay. And now it's just time to use it, I guess. PA. You know what happens if I just type that? Yeah. Right. So I guess, yeah. And this thing, and then we really set it in there though. At this point, we have our pointer to the PTE, and we actually do a bunch of stuff to it. And this thing still asserts. So the end. Okay. So see, it would appear as though we set it, like set, yeah, like it would appear as though that's set correctly. And then we just kind of make it out and we just return the function. So now I guess time to see what is happening in this check thing. Like I would love to know what these two values are. Also, wait, didn't I have some like macro that I was using? It's like xprintf or something. But it prints it out in just a U, which is not really what I want. But whatever. Okay. Okay. So I would love to know what these things are. does it return again? Fuzz T. Fuzz T. Yeah. Okay. 2PA. PA. Yeah, kind of annoying to type out that format thing all the time. Yeah, if I had like an actual testing framework, it would print out the variables for me. Like that's the if you use like Google Test or something like that, or Catch 2 in C++, it's kind of the point of having your own testing macros, so they can. So because this whole equality statement gets compiled just like gets resolved to a single bool, and so the assert function has no ability to print out both sides for you, unless you have a special one. Is that? Wait a sec. What? Okay. Did I? Wait, what? Did I save it? Oh, no. I keep modifying this wrong place. I think. Oh. Yep. Shit. Clipboard. Man, I just like wiped my oh, okay, let's bring this back. Okay. Render page size, page PA2. Why you coding in light mode? Hey Joy, I prefer that. It's a bit easier on my eyes during the day. Yeah, check page 2, page size, page 2 PA. Okay, so doing the same calls, and I just want to see what, yeah. Hey Mateusz. Check V8 to PA is returning that -1 thing again. Oh, wow. Hey, Wael. Hey, from Tunisia. Cool. So this thing is, yeah. Returning -1. And why would that be? Also where, yeah, right, yeah. So this thing, which is pretty much what we expect, but for some reason, and there's really only 2 reasons something can be returning -1, and it's because, and it's in both cases, is if the present bit is not set. Okay, so that probably means I'm not setting it somewhere important. Okay, maybe I can try to figure that out as the last thing I do here. Okay, so what's the, oh wait, okay. No, but I thought it was did you release your music? Not sure what you mean, Joy. So this was the relevant. I mean, okay, I'm just gonna add some prints to the check va2pa. How to improve your C coding. I think I don't have a good answer for you, unfortunately. I think you just need to practice. It's kind of like anything else. Find a project. Yeah, I'm using Vim in VS Code. What's going on? Fail number 2. Oh, got it. Yeah, cool. Yeah, Joy. Yeah, I produce music. Yeah. Yeah. I release music every 2 weeks on my music account, which is called Comfort. It's kind of hard to find. But if you look for Comfort Antimatter on Spotify, you'll find me. That's like a song I made. Fail number 2. But yeah, I didn't make any of the music that I'm using in this stream though. I'm just playing a YouTube video of copyright-free lo-fi music. Yeah, okay. So this failed. Wow. This is like hard to understand. Page dir, PT adder, converted to a K adder. So it looks up the page table, indexes into it. So what is the def? I'm gonna call it P, right? Oh, okay. 20-second break. I feel like I'm so close. I feel like it's very close to figuring out what's going on here. But I forgot a new line, as always. And right? So interesting. Wait a sec, but so I want to see the P. PTE. I have all these prints, but like they're kind of confusing actually. But, like, I feel like, yeah, I don't know if I'll be able to fully debug this time. I feel like we're pretty close though. Hey Ayla, I literally don't even know. Color scheme. Let's say color scheme. I feel like it's like the default light setting. Light modern. Yeah, very normal one. So the problem is I'm not setting the page table entry appropriately. And the obvious thing to do is try to print out Haley, yeah, I have a developer day job. I work on musical instruments at a company called Ableton. And so, why is this not working? Okay. Holy crap. Did I mess that up? Is it 0? Basically what I'm trying to do, like this is some code that's reading a page table entry, and I was trying to see first that it's reading from the same place that we are writing to in other places, and also the contents. I'm having some difficulty with that. I feel like I'm so close though. Page insert. It's really no. Like I'm computing something wrong. I was just trying to find the address. So this is like the check PA to PA. And I also I want to print out the address of it's kind of confusing. Just say header of page table entry. That's a bit simpler. Check. The check function. Okay. So now over here, for example, I kind of thought that's what I was doing already. I was trying to print out page insert. But this is totally different. And so we in theory, if we're doing this correctly, we should be writing to this page table at F03FF004. But in my insertion, I'm not doing that. PTEP is like this thing for some reason, which is just like wrong. But I'm getting super confused by all these prints though. There's like way too many prints now. And I think I can, I feel like I need a big print at the start of different functions. Okay, so not super, like not that much clearer. Page insert. The real question is, why is pager walk returning something so weird? And maybe it's just doing things wrong. So what's the code path that's relevant here? Not this one. This is the one where we like create stuff. So, and I am losing a bit of energy, I think, after thinking about page tables for so long. But really, it's not that hard. It's like, okay, we're trying to insert a page. We looked it up, I fixed a bug, and we are now correctly detecting that it is not like in use, and we return 0 if there's no page mapped there. So now this thing is null, which means we go into this path and we try to look up or wait a sec, what? Oh yeah, so we can't use this thing because there was nothing there. But just out of curiosity, oh, are they aliasing? They kind of are, yeah. I would be interested to see what the value of this thing is. I'm just going to do something kind of hacky. dp2 and see if these are different, which would also require moving this up. I don't know. Yeah. Okay. So these are not different. These are actually the same, which is at least kind of a good sign, I think. But it's just so interesting that it's expecting way different things. Yeah, I think panic test. That's what I kind of want. I want it to just like not continue until these two things are the same. Yeah, it's really, the question is these things are different. It's because now we can see this thing's trying to access here. So maybe I could fix this by changing like my code to do something very similar. And I'm observing that I'm just like not writing it to the right place. It's like way higher. Also odd, an odd number, which is not good, I think. So I think my picture walk is wrong. The question is, okay, one last effort at figuring this out. And I'm gonna go back into the debugger. This is hard. This is hard. Okay. And specifically, I'm trying to break here at yeah, dmap.c. All these lines changed all over the place now. So that is specifically it. Continue. Continue. And I am trying to step in and trying to kind of step through it. The info P is null. Oh. Right. So that's the happy path, and we should be going down that path. Now we're doing pager walk, right? And this is where everything goes off the rails. Pager walk. And yeah, I just want to see what the code path, what the code execution looks like as we go through here. PA, big if thing. And now we're at this thing, which looks a lot like here. So this must be where the bug is. And I really wish I could print things out. That would be so... Okay, yeah, I guess I can. Oh, wait, but am I... Let me open up my check VA2PA. How do they do it? So how am I doing it? Like they're doing it way more like elegantly than I am, I feel like. So what do? First, they look up the page directory. Taking the page dir and just indexing it at PDX, which is what I'm doing. Get a pointer to it. So they also have a pointer to the page directory entry. And then they do a check on it like I do. Wait a sec. Yeah. Okay, they do the check. And then next, then they dereference it. Oh. That's the issue, I think. Okay, I'm gonna kill the palm tree. I need to go, but that's the issue. I am masking it. I'm shifting it down 12 bits, which is not the right thing to do. The right thing to do, coming back to the diagram. Okay, what's the bug? I found the bug. The bug is. So what are we working with? We're working with a page directory entry, which is this structure. And it stores a physical pointer, in physical memory. And it does it stores a pointer to a 4K aligned physical address. And because it's 4K aligned, it can reuse these other bits. In order to take this data structure and convert it and like really extract out the pointer that's inside, what you need to do is you just take this thing, zero out the low 12 bits. And that's your physical address pointer. What I was doing is shifting it down 12 bits because I thought this thing was the whole address or whatever, but it's just the physical frame number. And I was shifting it like all the way down, which produces like a way smaller number. And I don't know, let's just see. I need to, and so what are they doing? They're doing PTE adder. If we look at the definition, I mean, we saw this earlier in the stream. It just zeroes out the low 12 bits. And that's what I need to be doing instead of shifting it over 12. And if I quit and do this, please. And now these things are actually equal, which is the bug. Okay, so that's the bug. So now I can remove this panic, and I don't know. It probably I think fixes the bug, but I Oh, interesting. Now there's like other issues with other stuff. Apparently, I'm doing things wrong with permissions elsewhere to change the permissions. So page 0. So maybe this is not that hard then. Insert. Okay, so am I ignoring the permissions? I thought I wasn't. Okay. All right, well, that will have to be for next time. But man, yeah, my brain is fried right now. But I'm kind of glad I figured that out, that bug. What's the implication of the bug? The bug is, the implications are like completely serious. Like the bug is a bug in the absolute core virtual memory operations. Like it's producing in this routine that kind of interprets these paging data structures. It is completely not finding the right things. Virtual memory just like does not work at all with that bug. It's like deeply serious bug, which is nice to have some tests. Yeah. Okay, great. Yeah, this was like my longest stream ever at 3 hours. I need to go. Thank you very much for joining. I have a Discord. I would love to see you there if you're interested in these topics. I'll post the link right here. Yeah, appreciate it. I stream every single week at this time. And I'll be back next week to fix the rest of the bugs and actually get this thing working. So with that said, thanks a lot, and I will see you next time. Peace. Bye.